Okay, the next talk is about an IDS on the network level for Androids, and yeah, let's see.
Okay, hello. I'm here to present the Android IDS. It's mobile security reloaded. First of all, let me present myself. I'm Jaime Sanchez. I'm passionate about computer security, and I've been working for almost more than 10 years with national and international companies as a trainer, as a professional consultant. I'm from Spain, and if you want to follow me, please don't use the method of Seba tracking my Bluetooth. Please use my Twitter account, and you can follow me on my blog. I've been a speaker for several conferences like Black Hat, DEF CON, and next week I will be with another speaker at Black Hat Sao Paulo. So let me speak about the motivations for this research. The first thing it's about that the smartphones has evolved into sophisticated mini computers. Do you remember the mobile phones when they were supposed to use it to call people? You remember the Nokia 5110 that it was supposed to only phone people and only send text message, but well, that's over. We are in a new generation of mobile devices that store all our sensitive information, all our private information, all of our contacts, all our emails. We do all the bank transactional things with our mobile phone. We can put our alarm of our house. We do everything with our mobile phones. So every year, there are tons and millions of mobile devices that are sold, and we can see that these mobile phones are susceptible to several PC-like attacks. You know, like almost 80% of the Android applications are vulnerable to man in the middle for SSL. So there are a lot of crashes about the browsers and in the operating system that belongs to PC computers and our mobile phones. So the importance of security mechanisms are still not yet understood, because you think that your mobile phone is only something you use to call your family, your friends, to use Facebook, but you don't realize that there are policies like bring your own device. So how many people doesn't take his mobile phone to the work? So you can be infected in your house, then go into your enterprise network and then infect and get all the information at your work stolen. So the security mechanisms are not sufficient. There are a lot of platforms in mobile phones, you know. There's Nokia, iOS, Android, it's BlackBerry, we have Windows Phone. But I selected Android. Why Android? Because Android is very, very, very popular for the last years. And being popular isn't always a good thing. Why? Because the malware and the threats are clearly on the rise. The attackers are trying to experiment with new business models, and are trying to put his focus, instead of the computers, put it on the mobile phones, because they think that they will be more vulnerable. In the second quarter of 2012, there were sold more than 100 Android devices. They have a market share of more than 50%. So these targets are very, very difficult for the attackers to resist. So let's talk about the platform. Android has the powerful base system from the Linux kernel. You know, it inherits the memory management, the multitasking, the file management, and it's a technology that embraces a great number of technologies like the Dalvik virtual machine. You can program in Java, you can do it in C++, and has a process unit component that provides the system function and server process. It's done with a thing that they call binder. It's a new thing they developed. Instead of using the IPC of the sockets or pipes in Linux, and it's done because of the performance. So this is what the official Android website says. They say that Android seeks to be the most secure and usable operating system for mobile platform by repurposing traditional operating system security, etc. There are a lot of things every mobile phone should do. It's protect your user data. So you have information of your credit cards, your bank accounts, your contacts, and should be protected in your mobile phone. It should protect the system resources. So it should protect too the network. That's the point that we are going to see in the next slides. It should provide the application isolation. In this case, in Android, this is done by using each process has an individual sandbox. And as they say, Android provides some kind of security features that are mandatory application sandbox, I have said, security inter-process communication through the binder. You have to sign the application, but there has been some problems with that with the Android master key. And every application must tell us what kind of permissions does it need to work. So this is done in a hierarchy. This is several levels, and each component assumes that the component before has been doing his work properly. But there is a problem. There is a massive growth of the volume of malware families and samples, and the difference between the Apple Store and the Google Play is that they have developed the bouncer. Bouncer is supposed to be some kind of intelligence that try to know if an application is malware or it's a good application, and there has been a lot of ways to trick it. So, but this is the only problem with Android. It's not only the malware. As you can see, these are the versions 1, 2, and 3 of Android. As you can see that there has been a lot of exploits and vulnerabilities. There are remote code execution, privilege escalation. They have denial of service in the Dalvik virtual machines, denial of service in the SMS. There are a lot of things. I didn't put the version 4 just because I didn't have enough space in the slides. But there are some of the things that have been very important. The USSD exploit, we will see. There is a poor SSL implementation on the Android platform. Almost 80% of the applications are vulnerable to man-in-the-middle attacks. So you can extract all the sensitive information. There has been some kernel mode driver exploits, some vulnerabilities in the NFC that could compromise the mobile phone. The problem with the Android master key that has been, I think it has been patched by Android like 3 times. There are 3 variants of the exploit. And the last thing is the Meterpreter model for Android. Not only this, but day by day, we can see that there are new exploits coming. In the mobile point-to-own, they have developed 2 exploits, one for the Nexus for Chrome, that it exploits an integer overflow. And the other one results into a full escape of the sandbox and remote execution. There has been another problems with the default applications installed in the Galaxy S4 that could lead to get some personal information of your device. So I decided that I could do anything better than the things I have seen. So I was looking in Google, and I came to the first version of the application that was to create a VPN tunnel between the Android device and my computer. As you can see, the VPN goes to my computer and my computer to the internet connections. I use the digital certificates with a public and a private key just to authenticate the mobile phone in my computer. This is done because we are supposed to give some flexibility, because if someone loses his phone, in this way you can delay it very easily. And once the VPN tunnel is stabilized, we can begin like analyzing all the traffic that our mobile phone is sending. So I tried to get the two base signatures. The first one was the official of Snort, and the second one is the emergent threats. And I use some programs like TCP dump and the other one was Wireshark to have a complete preview of all the data that was sending. But I failed because there is a problem. I'm capable of analyzing all the traffic, okay? But I can and I can act like an IPS. I can block when I can discover any bad traffic. I can send notifications to the user, and the other thing is like, well, this is great if you are in your home or in your corporate network, but when you are on the street, you have to send and receive traffic from the 3G connection and then duplicate it to your server. So if you normally use like 1 gigabyte of information as 2, you have you must duplicate the bandwidth, because you have to send the information to your computer and to the internet. So for me, life continued. I continued doing any other things, and this is the way I found how I could do the IDS thing with Android. I went to the Black Hat, to the Arsenal. I was presenting a tool that was supposed to defeat the Nmap fingerprinting and POV and some commercial appliance, because the Nmap internal proofs have this kind of fields. You have to be able to modify and check things in your packets, like the options, window size. You have to put the default fragment bit on or off. You have to expect to modify the TTL. And it was the same thing in the POV. In the POV, you have to analyze the window size, the TTL, the POV fragment, the whole packet size. And very important in this thing is that you have to put the TCP options in some kind of order to make it work. So let's see. I have to do everything of this, and I have to modify and intercept all the traffic in real time. So I came with a solution. I began programming this in Perl, then I go to C, then I go to Python. You know, it's that kind of things people do. I see that we are putting Nmap. I'm gonna fool and try to act like Microsoft Windows 95. You're gonna see here is Microsoft Windows 95, just to know that people can say, hey, you have tricked with the signatures, okay? With Windows 7, I didn't modify the signatures, it's been read. In this case, our Linux system is Windows 7. So I came to this idea, and when I was presenting, I thought, well, I have developed our tool that has nothing to do with Android, but I need to process the traffic and modify it in real time before it gets inside the Android device or it goes outside to the network. So I can redirect all the traffic from kernel space to the user space, and I can do whatever I want with the packets. And I can do it in real time. I can run it continuously. That doesn't need a human supervision. So why cannot use this technique to develop an IDS? I could detect the traffic in real time. I could block the packets. I could do whatever I want with the network traffic. So I got it. The only difference was that I was supposed to write the program in C again, because there is no Perl and Python bindings for Android. So let me explain how is this done. As you know, the computers provide different levels of access to the resource, and this is done this is enforced by said CPUs to provide the difference level by hardware. So there are some kind of rings that goes from the most privileged, that is the ring 0, to the less privileged, that is the higher number. So why I'm telling you this? Because in this case, all the traffic are in kernel space. You can do the trick in user space because you are unable to touch any kind of traffic that doesn't belong to your application. So kernel space is strictly reserved for running the kernel, the extension, the drivers. Is where we can connect to the hardware devices, and the user space. It's that kind of space that our application runs. So if we must do anything to interact with the kernel, with the hardware, we have to let the kernel know and make some kind of calls. So this is like more or less the map of the networking, storage, and so. But man, this is very complicated. So I will try to explain you the thing or how a packet goes from the network interface card to your application. I call it how I made your packets. At first, you have your a packet coming. It goes to your NIC memory. I don't know if you can see it from there, but it goes to your NIC card. And in your NIC card, it can go to an internal buffer, or it can go to a structure inside the kernel that it's a buffer memory that it's put using the direct memory access, the DMA. Then, when we detect that we have a packet waiting, we launch a soft IRQ and let the CPU know that there is a new packet that it will hold. It will call a hard IRQ, will save the registers, and will begin by analyzing all the packets. The next thing that you see is in the path before entering the IP layer, there is all the IP tables chains the packet must cross. You have the mangle, you have the forwarding chain, you have the input. All the packets that go inside to our applications must pass through the input chains, and then it gets to the TCP/IP stack. Here is the part where we analyze the headers, we analyze if we have a good checksums, and we are gonna be removing all the data until we get to the user space that we search for our application and say, hey man, who is waiting for this kind of packets, and we pass through the user space. So in this thing, in this path, the only part that we can take our work done is with the IP tables. You know, there are several extensions in the IP tables. The accept is just to let the packet pass. The drop the packets. Reject is the same as drop, but tell the remote system that you have been dropping the packet. But there is one interesting that it's called queue. The queue is a target which queue the packets from the kernel space to the user space so you can process it. To know it, this is done into a fixed length channel list. There are two fields. One is an integer to identify the packet, and the second is the metadata of the packet. And there are two components that are needed for this to work. One is the handler that deals with the mechanism of passing the packets from kernel space to user space, and the user space application that have to take the packet and take any verdict to it. You have to be you have to take care of the length of the queue because it's like 1,000 size, and when the queue gets completely filled, you are going to be discarding packets. So you can create several kind of queues and putting your packets inside of them. So with this theoretical intro to the NFQ that that's what I'm gonna use, I will start presenting the Android IDS. I think that the logo should be something like this, but please don't make any decision when you're at Vegas, because I promise you that this is the official logo for the application. So I promise that Android IDS is a serious open source network-based intrusion detection system, and important, it's a protection system that has the ability to do real-time traffic analysis and packet logging. It should feature some kind of things that are protocol analysis. It should do content searching, and it should do content matching. The architecture is very simple. There is one sensor and one server. the sensor runs inside your Android device. There is no human supervision of the process. And it should do some kind of things, like it should analyze all the traffic you are receiving and sending to the internet without letting know the user. It should send push, some kind of push alerts to your Android phone, because there is nothing to do if you're being attacked and you can see on your screen. It's gonna report to a central logging server, and it should deploy some reactive actions. It can drop the packet that we can see that is being suspicious. It can add a new rule at the internal firewall, or it can launch some kind of modules that I'm implementing. It's gonna sync with the server, and this is very important. That should impose minimal overhead to the device, because in this case we must think that we are inside a mobile phone, and not all the mobile phones are like the Nexus 5 that has a lot of cores, a lot of RAM, and if we begin like enqueuing all the packets and we have all the queue full and we cannot process all the traffic, we're gonna begin like dropping it. The other part of the server, it's a Linux box. It's responsible of sending the signatures, storing the events in the database, detect the statistic anomalies, and you can do here more things, like you can implement a CM, and you can put all the traffic to the CM and do any kind of cross-correlation, whatever you want, or you can store it in your syslog server. And something that I should work is in the collaborative detection, when we have several mobile devices, we can see what kind of malware are being run, if it's going to be infected in all the terminals. There are some reactive actions that could be interesting, like uninstall directly the application that could be found with malware, kill the process. But another interesting thing is if the user doesn't uninstall the application or doesn't let the process uninstall the applications, disconnect the radios. So if you have a user that has been infected and doesn't take your advice, you disconnect the radios remotely and block it so it cannot be launched anymore. Another interesting thing is monitor the syscalls, but here is a problem, because to monitor the syscalls, you have to find the address, and when Android 1, Android 2, 3 are different addresses, and it depends of the manufacturer. So there is no single way to make an universal plugin to monitor the syscalls. So I think this is going to be delayed. So the first thing that it should do our IDS is protocol analysis. Protocol analysis is analyzing all the traffic you have in your mobile phone, just looking for some kind of characteristics that doesn't adjust to the standard. In this case, I have analyzed a packet, I have disassembled it, and you can see that it has the thing, the synchronization, the push, and the urgent flags activated. In this case, this is not good traffic, so we are going to drop the packet and we are going to report to the remote server. I program all the fingerprint part for the other tool, so I only have to port to C, and this is the beginning of the tool. I have to fool only 16 proofs that Nmap was sending to our computer, and that's what I did. There is an important thing that you should know, that is you have to have a root in your terminal, because there is no way to link to the IP tables without being root. So you have to push it from your computer and launch it in the command line. I'm working on a application, a visual application that you could use to launch it, but still there are so much things to do, and I think that the graphical part could wait. You see that I have launched an Nmap. In this case, they say it's a Linux box 2.6. But what we are going to do, we were detecting all the Nmap analysis, and in this case, we're going to launch the Android IDS, and we are trying to fool the Nmap and told him that we are another phone. You can see that they are detecting all the traffic, and the result of the analysis of Nmap is the device is a Sony Ericsson in bed, this WV715. So we have been able to modify all the traffic in real time. We can take all the rules from IP tables, and this is the interesting part that I use Notify My Android to push all the alerts. So there has been 2 alerts. One is it's telling the user that it has been scanned from one IP direction, and the second one is that it has been scanned from an IP direction, and we have used a reactive action that it's trying to fool the scan. Another thing that we should look is the pattern matching. Pattern matching is just building a signature base. In this signature base, we are gonna put all the strings we want to search that are related to some port, related to some service. Here, it could be very interesting to implement the stateful pattern matching, just to look for a string into an entire flow of the connection. But this leads us to the signature format. I have built a custom signature format. It can be you can import all your rules from Snort to these kind of signatures. I have added some signatures from Snort and from emerging threads. There are not so many interesting things in emerging threads for Android. And I have developed a script that takes all the, sorry. I have developed a script that takes all the signatures database and converts it to something friendly for the program. More examples. Android use after free remote code execution. This is a vulnerability that saw the light like several years ago because the browser of Android doesn't validate some kind of data. When it tries to free it, user can execute some arbitrary code. In this case, this is executed via an HTML that a user only has to visit, and you only have to put a netcat hearing in your local port, and you will have a cell in the device. The other thing that we spoke about was the USSD exploit. The USSD codes are some kind of code that you can put inside your mobile phone just to perform any task. There are some tasks that the providers give you that it's like call forwarding, to make inquiries to your invoices, or the same functionalities. And this is the way that gets into the HTML website. And the remote exploit, what is going to happen is that it will try to erase all the information of your mobile phone. So this is interesting, but we're going to see that we can develop and use some signatures from the web service to try to detect and to block all these kind of signatures. This is a real device that is working in Android 4, so there are some things that won't work, like the use after free. But you can see that it's able to locate all the strings and the patterns belonging to this kind of exploits. The first thing that we're gonna see is the use after free. You see, it has been detected like the CVE 2010-1807, and the Android 4, that is the browser crash. It's a denial of service inside the browser, and it has been completely detected. And the other things that we are trying to detect in these web signatures is the USSD. I'm inside the test website, and you have seen that the web attack, the USSD code is being printed in the screen. In this case, it was only trying to show the email, but the attack has been detected and it has been blocked. And the last part is the part of the malware. I don't like the malware analysis, but I have to do it, and you can take some malware examples and try to search for patterns or strings that belongs to the applications. In this case, it was the SMS send. You can download it from any Russian page. You have to see that it's a double flash player in Russia, it's a double play new in Russia, etc. And once execute, it connects to some website with a pattern that it's rq.php and then sends all the email information, contacts, whatever you want. And the other thing that we have been speaking is the meterpreter. Meterpreter is a friend of us. It's deployed inside the Metasploit, and it's an stager that goes inside an application that could give you things like command story, and it lets you inject some kind of process inside the remote machine. So what we're going to do is try to see if we can detect all the things that the meterpreter are using. The first thing, as you see in the other example, is you have to be root inside your mobile phone. And I don't know if maybe you can see it, but what we are doing is launch the Android IDS, and we are putting the signatures like in the meterpreter. We are logging it, and we have been using the meterpreter module. We are putting our computer to listen to any connection. And the next thing we're going to see is clicking inside the reverse TCP in our Android mobile. And we will expect to get a cell. You see? We are waiting, and now we have a meterpreter inside our Android mobile phone. There are some kind of commands that you can put inside your cell. For example, you can get all the local information. And every command that meterpreter has inside, there is a signature for it. So what we're going to see is that we have to do the PS to get all the process running inside the mobile phone. And down, you can see that the process list request has been detected by the Android IDS. It has some other features like recording the microphone. It can browse all the file system. It can also download any file that you want, and anything that we are seeing that we can do with meterpreter can be detected by our Android IDS, because we have a signature file for almost everything. In this case, we have a cell, but there is some important things that the example will go on and will try to block all the attempts made by the meterpreter, or we can block one command. To block one command, the only thing we have to say is, hey, I want to block the camera. I want you to browse all my file system, but if you try to connect to my camera, drop all the packets. This could lead to something very interesting, that is that you can do any kind of jail for the meterpreter, because if you get a connection and you know that this meterpreter where it's inside your mobile phone, you can answer all the requests that it's doing to you. So if it shows like, hey, send me a picture, you could take the program like, hey, send a fake picture with another guy. And the last thing is that everything is going to be recorded inside the remote logger. It's going to be recorded inside the mobile phone, and it's going to be recorded and notified to the user in the Notify My Android. And I think that's all. If you have any question.
Any questions from the audience?
Since the IDS stuff isn't really process cycle friendly, how much of my battery will get wasted?
Not too much. I have the last time that I was doing the performance test was in August, and it was like 5% of the battery life. Because right now it's only analyzing some parts. There are some only not all the modules are being activated, and it's like 5%. But you have to take care, because that's the reason I don't like to do the live demo with this system, because if you get inside a Wi-Fi and you begin like receiving a lot of traffic, the problem is not that it's gonna consume all the CPU resource. The thing is that the mobile phone is not gonna be capable of analyze all the traffic it's been receiving. So it will begin dropping all the traffic, and it could be a mess. So what I'm trying to do is to analyze only some kind of things, some kind of patterns, and try to optimize all the algorithm, because it's not very important for the CPU consumption. It's only important for the queue not to get filled and begin dropping all the traffic that you receive.
More questions? Question from me, is code available for that?
What?
Is code available for that from you?
No, it's been developed, because I have, this is the thing of doing this kind of things, that I begin doing the main code, and then I've been doing the modules, and I have to mix up.
Okay.
But
so
I think that it will be available by the end of the year, because I have to travel next week too. So I hope to publish it at the end of the year.
Okay, cool. Any more questions from the audience? So then we are a little bit early for a coffee break. Maybe you can discuss with him in the coffee break further. So thank you very much.
Thank you.